So like a quick introduction, my name is Rajdeep Sengupta. I am Director Systems Engineering in AMD, and I'm today with my colleague Amlan and Prem. A couple of years back, we started this Iceberg journey. At that time, it was very hard to push back all other different silos, and we'll talk about the story, but today's main presentation is more about the use of, like there was a question that what you can do, why you need an AI, so maybe we will touch on that more, right? So we'll explain what we are doing, right? So maybe a very quick introduction. I will not bore you with AMD, but one thing I realized that a lot of people don't know about the AMD's full length of, we touch from space satellites, to cars, to your laptops, to your data centers everywhere, Just to give a glimpse of what, just on the AI side, not on everybody. You have Xbox or, your PlayStation is also on AMD platform. But, just look into the AI spread, right? You have cloud, which is all the GPUs, instinct-based, and then HPC, which is basically a GPU and a CPU combined, is called the APU. That's for the HPC, and the biggest one, El Capitan, which is still on the AMD platform, right? Actually, the number 2 is also on the AMD platform, to be honest. And then in the enterprise side, this portion you probably all know, that starting from the edge to the compute, like we have the EPYC-based Generation 5 now, Turins, and on the other side is the Instinct side of the house, which I already covered, and of course PC. And in the PC, you know about the Copilot PC or AI PC, right? So AI PC has like certain tops. You need to have a Copilot to have certain tops, which means you need a CPU, you need a GPU, and you need an NPU. Then only you can reach that 55 tops or whatever you want to do for the Copilot PC. So that's all. And then one thing which is like a lot of people doesn't know is the adaptive compute and accelerated computing, right, platform. What is that? It's a system. The Vercel series of the chip is a system in itself. So it has a general purpose CPU, which we call it the ARM Cortex. So yes, we are also in ARMs. So ARM Cortex 72. Then we have on top of it the FPGA or the logic fabric. So it's an adaptive, because think of it, if you need something to accelerate, you can actually use, because it will accelerate. So I will give you an example. Let's say you are doing a query engine. So query planning and all you did, but now you have to execute the query. When your execution plan is ready, you have to speed up the query engine. What you do today is you can create multiple executors, right? Instead, you can also use the adaptive computing, because even though the FPGA fabric works in a much, much lower frequency, but it is highly optimized for that particular purpose. So it will accelerate you. And I know that someone I met today from Saturn Data or somebody, he's doing a lot of acceleration of the pipelines using FPGAs. Plus, it has the AI accelerator, which is it has an NPU, it has a DSP block. So in that small chip, it is everything. So just to give a context set, if you are interested, let me know, okay? So now going to the topic, right? I think I will not repeat much of it. A lot of you have already heard. By the way, these slides are not I created. These are created by Claude when I prompted it. So it's not mine. So you will see some of the lags because it cannot see itself, but at least if you give couple of prompt, it adjusts the space. So these are, but it creates images. So I was worried that when you present in a bigger slide, it will kind of, the resolution will not be high, but it looks okay here, right? So what we are talking is, which you all probably know by now, that we have these silos of data. And 4 years back when we started this Iceberg journey, I was being asked in the company, hey, is it a snowflake? Is it another tool you are bringing in? Why we need to change? That concept of democratization of the Iceberg was the most important part, which we need to tell a lot of stories to kind of democratize it. And today, we are, with the help of my team, we are able to consider not only all the different part, wherever it's analytical requirement. I know there are different kind of database requirement, but if it's an analytical data, this is the place where you kind of consolidate everything. Now, the beauty is that once you consolidate to Iceberg, and we've been using Nessie REST catalog for a while, it serves our purpose. I know we talked about Polaris, and there are many other Unity and other catalogs, but and I think it is, in my opinion, you choose anything which is Iceberg REST, as long as it is open source and you get all the support, you are good at it, okay? But and on top of it, any analytical engine which understands REST can work, right? So it could be Spark, Dremio, like we use all these four, actually. Databricks, Snowflake, Iceberg, and Spark engines as well. Going to the next, I think this slide also I will take, sorry. Yeah, this slide is kind of give a very high level that why we adopted Iceberg, and I don't have to explain this forum because this forum is already, understand that, that's why they came in. But one of the two major pieces is the kind of, the scalability Iceberg provides is huge, right? And then the ACID compliance and the fine-grained access control. Yes, actually in our data, it's not that you control at the higher level. In our data, every row of data have access of it, because we are into a semiconductor industry. It is very important, everything is group-based. So you add that fine-grained access control at the level of every row, so that any engine which reads on top of it just honors it. All the UDFs are defined so that it honors that particular, it's like a, you member of or kind of UDFs, right? And it will honor that, and your data will always be secure. So, now, when you have an Iceberg, you need to optimize also, right? So the partitioning strategies are important. You can have two-level of, or multi-level of partitioning strategy you need to do. So that's one area. Your query optimization, I'm sure you all know, all this engine we talked about, including Spark, Dremio, Snowflake, they actually do the predicate push down, which is basically makes you performant. And since these data are columnar, Parquet is a columnar data, so you can just, it's very fast if you select, because you don't need all the data. You just need probably one column or two column. And if you have those filters which goes down as a part of this predicate push down, that helps, right? Since we use Dremio, so people who use dynamic tables in Snowflake, we use Dremio also. So we use reflections, and reflections actually is very helpful because you can cache and get the query much, much faster. Now in the table maintenance, we struggled a bit initially because table maintenance is not easy, even though you partition it correctly, because in the engineering space, we deal with petabytes of data. People don't always kind of have a thought process in their partitioning strategy, but they don't go into, so we need to do constant, I would say, the hygiene of the system, right? We need to maintain, like table properties and like, optimization and the vacuuming technique. And then one thing which I realized that Iceberg is not good at time series, but in a world where we have a lot of, facts, a lot of fact table are time series based table. You need to have all this kind of data. So we run our job to make it from fine grain to coarse grain. But my request for V4 and above is maybe we should look into make it also like a time series. It's time series aware data. Or if you have some ideas, I would love to learn from the people who knows it, right? Now the story begins, okay? This is all kind of getting a stage. So now you have all the data in one platform. What are you going to do with it? Yes, you can give it stewardship, based on the data stewardship, you give it to different people, they run the query engine, right? But then the idea is that if you have all this data, why not you use it to build a data intelligence platform, okay? So here is the high-level architecture of the data intelligence platform. At the lowest, we call it PCH, plumbing, curating, and harvesting. And what plumbing here means in the infrastructure, where you bring in all the data lakes, create the data lake, bring everything in, push the curation, harmonize it. Those are the part which we call as the plumbing. But on the next layer is the layer of basically building that intelligence. Because think of, let's say you have 10 tables, okay? Now you want the data from one table, it is easy, right? You know it. But if you have thousands of tables and you want some data, some AI, now think about his question about the AI part of it. If AI needs to learn, It's not a magic, right? You put an expense as a profit or a frequency as a column name. What does that mean? That might be existing in 10 different tables. How do you correlate that data? So you need to build a metadata. So we actually build for every table we have, every table, every column, the schema description, what this purpose is, what this column means, that we tell, and not in a human language. It is in a more like an LLM language, because it understands the keywords. It doesn't need the whole sentence. So you don't have to make a very big metadata for each table. So in our metadata table, each row is a, it points to a table and its information. I'll show you, and at the top is the kind of, and I'll talk about the knowledge graph also in the next slide. But at the top is the harvesting. Harvesting could be as simple as your dashboards, which you get a Power BI dashboards, or you have a chatbots, or your agentic framework where the agents can talk to it. That's all kind of in the harvesting layer. So I want to spend a little bit time on this slide. I think this creates the intelligence, right? So with an example, okay, so let's say there are 3 tables. One is the device table, one is the application, and one is the user. Let's say a user uses a device, and the user also uses an application. And then the application is running on that device. Let's say this is the kind of 3 data, and you are getting a lot of metrics or data points out of it, right? Now, if you build a layer on top of it to explain it, to build a relationship. Now you are done with all this. You have an MCP, let's say, and you query it to get an answer. Practically, I tell you, it works with 10, 20, 30, 100 tables. When it goes to thousands of tables, it is very hard to create those relationships. You will join up to 2, 3 is okay. But what if the join needs 10 different tables, right? The context becomes so much confusing that it is very hard for an LLM to build a query, even with the help of MCP, to get a very realistic answer. Now, why we are doing all this? Because, LLMs are very smart. Why? Because they have the data of the internet. They are trained in the internet data. Where is the next fuel of data rise? It's on all the enterprise. Inside the enterprise, we have all this data. Earlier, they were silos. Now they are consolidated into one place, right? Let's say you can, to some extent. Like, for example, in our team, IT, we have already done it. We consolidated all IT data into one single, and all the pipelines, thousands of pipelines are coming in and pushing data every, based on the cadence of the data source, right? Now, if you have all this data, can you build an intelligence on top of it? So in order to build an intelligence, you need to be very context and ground aware. If you ask, people can ask a lot of questions, but those questions need to be very grounded. How do you ground it? In order to ground it, based on the this metadata, you create a graph layer where the graphs comes into picture. So what happens is, in this case, like as you can see, the relationship, the user, the device, and the app are the nodes, and the relationships are the edges. This is how we create the whole graph. Now, when you ask LLM to a very specific question, then it is much more context grounded. So it gives you a very perfect answer. And you can ask my team, like now it works perfectly. There was never ever a single situation where we are not able to answer any question. So we have a chatbot today, right? That chatbot, you can ask anything based on your permission, by the way. It honors your permission, because in the graph, we have these properties, like, graph node has properties. So you can define the properties to match whatever is in the data lake. Now, there's another problem, though. How do you load the data in the graph? Many tools you get, they cannot load the data in the graph, and our data in the Iceberg table are coming at a very high frequency. So that's why, the graph has to be adaptive, so that the graph can directly point, and we don't have to have a different pipeline to load it in the graph. And once this is done, your LLM will work, and if you want to share it, because it's not only chatbots, you need agentic framework. Your agent wants to talk to and make decisions, and I have a slide to cover that. That will come out of the MCP layer. So the zero ATL graph database, which we use in this case, in our case, it is a puppy graph, and I'm sure you saw it. I see some of the folks are here. So the reason which we chose is there's a zero copy. You don't have to copy anything. It is adaptive. Actually, it has two modes. One is the adaptive mode, and another is the cache mode. If you have a sub-millisecond kind of requirement to very fast query, of course, you have to bound it with how many hops it should go. So you can control all that, and you do it, right? It's a full cache mode, and it has an kind of a schema evaluation. If your underlying table is schema evolving, it understands it, and it load it, as long as it has the information in the metadata. And also, it is it can be deployed in a K8s environment. So, like in our case, we have the leader node and the execution node, so we can have very high performance. If you need more and more performance, you can load it all in memory. But if you don't have much memory, you can mode in the adaptive mode. So then, as and when the query comes, it will take some time initially to load it and do it. But it's not that slow. I'm just saying that depending upon your use case, you can do it, right? So this is the kind of tech stack which we do. So at the bottom, we have Minayo, because it's an on-prem implementation. We are now doing in the cloud as well, because there are some use cases there. On top of it, we have this Iceberg with the Parquet data file. Then we use Nessie REST catalog, and Spark and Dremio both. Actually, we are also working with Snowflake to make it enable. And then, the Dremio's query engine. So Dremio works also, they have a feature, I think a lot of engines have a feature called copy into or merge into. A lot of these data like CSVs and JSON, you need a SQS kind of hook. And as soon as the data lands, it automatically load into the table, right? And once the table is loaded, the graph will take it, and any query comes from the agentic side, whether it's your agentic framework is LandGraph, AutoGen, CrewAI, whatever you use, right? Or Copilot Studio. So it will kind of query the graph using, if you need to give it to other agents, you can put MCP. And then we have a method called agent and critic. So we use Claude for asking, it creates the query, and then the critic always look into, before answering it, it looks into, have you understood the question? Because people can, when they have a natural language, people can ask anything. So you need to converge and make sure the data, what he's asking, and what the agent is answering is correct. So these critic agents solve it, and if the critic agent and the agent doesn't agree, then after one try, it goes back to the user, say, have you asked this question? I'm not clear. Can you ask very clearly? Give me more context. So otherwise, if the critic says, yes, what you have done is correct, it just goes and gives the answer. So I will stop here. Is there any question? Because it is important. Yes. Yeah, well, very good question. So, in order to have a PII, we have to have a very strict, every company has a very stricter rule, right? In this case, because we deal with a lot of engineering data, we haven't added PII. But think of it, if your security is built in at the bottom layer, at the layer in which each row of data, it should percolate above. You are not controlling anything above. In the graph also, it just follows through what is there in the data itself. So that's why we feel like it is much more secure. But but we particularly on our use case, we don't deal with PII data. Yes.
So for the representation between like the Dremio step and the puppy graph step,
yeah.
There we go. So for the representation in Iceberg, I guess, is in that Dremio step, is that like already converted into like edges and nodes, or is that going to be like, is that what that Dremio step is doing?
Yes. So in the graph, in the puppy graph, you have to set those edges and nodes based on the metadata, right? We are trying to develop an engine which we can, which will read the metadata and continuously evolve. But once your schema is there in the graph, you don't have to do any more loading. Schema has to be built. But I think there is a room here for us for future to build the schema automatically based on, because we already have the metadata. We know what data is coming in.
Awesome.
Okay, so so in summary, what we get, right? We get a business impact. I'll start with the kind of the success criteria, right? So since we are IT, our goal is to reduce the MTTR, right? Improve our quality of service. How do you get that? Reduction of the cases. One thing I told you that many a time we start with think about AI ops, but AI ops is like anomaly detection, right? Anomaly detection is too noisy. That's why it has not got into, it is a 10, 15, 20 years old technology, but it has not got into success. Now, with all this engine, what you can do is your agent can continuously look into various data sets. Let's say you are getting from multiple data sets of your IT. You look into the anomaly. You create a baseline. You look into the anomalies. You don't just shout those anomalies or send those anomalies. That will be too much of noise. But you start learning it and create a graph again. It's called a dependency graph. And now once your dependency graph is built, you validate it in next iteration. In 6 to 8 months, if the events are happening correctly, or it may take a little bit more time, your graph will adapt. It is not a human which is building. It is built by the system itself, by learning the relationship. That if this goes down, oh, I see when there is an anomaly here, there is an anomaly there is an anomaly in other places, which means they are correlated. Let's first understand that these are correlated. Next step, hey, which was created at first? Where you got the thing as first, right? And slowly it will learn that, and then we are actually doing a paper on that to kind of learn and develop. So if the paper published, I will share with you. But that paper talks about how those dependency graphs are created, and then how do you do the anomaly detection based on that, based on that graph, right? Similarly, for standard operating procedure, let's say you do certain work which is very mundane, self-healing, right? For example, if the machine kernel just hangs, then the machine needs to be rebooted. You cannot do anything. So, these are very standard procedure. Today, you can make an agent to do all that. How they will take the decision? They can take decision, but if they need more information to triage, they will go to that platform, query it, and get it, right? So those are the kind of success criteria we are thinking, and maybe because of this also we are making faster decision. In a leadership wants to take like a view of something. Let's say, how much is my cost of doing this business or this particular service? Earlier, they have to go to a dashboard. No, I don't want this. I want something else. They have to recreate or tell someone, hey, get me this data. It takes a lot of iteration. He can go and now do it a query and work with the query engine and get all the data. That's the value of what we get in the with the AI. It's not just a simple data. It's not a semantic. It's just a semantic layer creation. It is more about getting the intelligence in the hand, in the fingertip. We call it like a crystal balling with your data, right? And so what is the next step, right? So next step, in our is like I think there's a talk about multimodality. So one of the main challenge is the multimodality. Because text is fine, but there are a lot of images we need to deal with. For example, your invoices. Let's say in Concur, a lot of people put expense. Those are images. How do you take those images, build an AI pipeline which can extract the properties, keep it in Iceberg table, load it in the graph, but today I have to store it in a vector database. But maybe in future, we don't have to do that. So that's one of the area. And in terms of the whole agentic ecosystem, these are the 4 when we work with. I already talked about AI ops, digital twins. What is digital twin means? Whatever you do, let's say somebody else is doing for you. For example, let's say you train somebody what you look for. For example, a presentation. Let's say you get a presentation. What do you look for? I look for only 3 things. What is the when my team does it, right? What is this, what is the problem statement? What are you trying to solve? What is the solution provided? and what they need from me. If these three things is not clear, I should send an email saying that, hey, can you highlight these three things in your presentation? I don't have to look into my presentation. Or I just give an idea, and like Cloud is making those images of my thought process, it will also create presentation and send it based on what I prompted, right? So, like a detail, or in your simple laptop, right? If it is like your PowerPoint or something is hung, it will tell you, hey, generally you take this much of memory, today it is taking more memory. Can I restart it? Can you save your data? Or at your evening when you're sleeping, keep your machine on, I will do those hygiene stuff in your laptop, right? So those kind of things is there. Self-healing, I already talked about, and then the agentic workflow. We believe that soon processes will be gone. Why we create the process? Because there is a guideline you want to, so that humans can focus on it. You want to give access to it. For that, there is an approval. There are 9 yards to complete. If this can be taught to an agent, it can do it itself, right? You don't have to have the process. So these are the kind of areas of focus for us in AMD. That's all. Open for more question if time permits.
You are giving a prompting for that workflow, right? The last option.
Yeah. So workflow is like, let's say, so thank you. So workflow is like, let's say you want, a simple workflow could be an NDA. When I, let's say, went with PuppyGraph, so we have an NDA you need to share so that we can start the journey, right? Mm-hmm. I have to put all these details which he has sent, put it in a system. Somebody will look into it. They have an approval process, goes through it, and then there is not much in the process. It's a very standard process, but it still takes 2 days to complete, right?
Yeah.
So, it can be done by an agent. So that's why I'm saying that those workflows, which is like you do, it's very like 5 steps you do, and those 5 tests, there's nothing, great about it. It is just that you are following that process or not. If you can do it by an agent, then you don't need a human for it.
So auto healing is a debugging purpose or also operation purpose?
It's both, right? So, okay, like let's say the example. So you have a server, let's say a graph server, right? And that server is not behaving properly, okay? Because what are the signals? The latency is increasing, number of errors coming is increasing, right? Traditionally, it will open a ticket. A person will look into those tickets, right? And then they will debug it, and then they will fix it, right? Yeah. But let's say this, in the data intelligence platform, we have all the tickets. We know what was done 10 times, 20 times before. It's nothing new. So it will get that knowledge, do all the checks, and fix it automatically. Okay. That's the auto healing part.
It connects to the GitHub repository and the previously deployed. Means what I raised this question is, I think 2-3 days before I saw the Google Yuli something. They are giving the service for debugging and all those.
Yeah. In our case, the data intelligence platform has all the. We are continuously getting all the ServiceNow tickets and every other tickets, Jira tickets and everything. So it has all the intelligence. You can search that if there is a black screen on an ETX node, what are the probable problems in AMD, right? It will go search all that and say, most likely this is the problem. If not, this is the problem. So you as a human also do that okay, this problem, let me check it, whether this is the problem or not. And there are certain signals or trends through which you debug. That knowledge is stored here, so you can, so that agents can do.
So I think you build the knowledge graph.
Yes. Thank you.
Thank you.